Alright, you ready? Sure. Okay. 5, 4, 3. Hey guys, so in today's video I'm going to be going over pretty much what I went over yesterday, and likewise I'm going to go ahead and pretty much create some new flashcards now, or not create new flashcards, but like go over newer flashcards, so then I have other things to practice. Now, as a recap and as importance for understanding how to recall things, like if you recall something you'll remember it better next time. I'm just going to quickly go over a couple of things that I saw yesterday that I worked on. One of those was using the index, being able to identify unique values in the index position, and the index position is listed on the left hand side right here. Likewise, you could also use dataframe.date, like you can select a specific column and see if those values are also unique. So let's go ahead and bring this in. And then that's false. But if we were to go ahead and see what the index was, we'd see that it is true, because each of these would be its like own row. So if we were to see the top 20, we'd see 0 through 19 on the left hand side, and in essence these would all be unique values. So you could use .isUnique to identify what you might potentially want to use as a column to join on or merge on when working with data analysis, and likewise just maybe even if you wanted to index that position. And what I mean by index is like, is it index? I think I'm blanking, but essentially you select a column and you say that this column is going to be one that the computer should memorize, like the pathways, getting into computer talk. But in essence, when you join on an indexed column, if I'm not mistaken, those columns join together faster, which causes your pipeline to go faster as well. So you just remember, primary keys should pretty much be identified with isIndex or isUnique, .isUnique. Next, one of the things we went over yesterday also was setIndex. In essence, we're just setting what the index would be. So rather than having it be just like a blank line right here, it would be, we could set to whatever column we wanted our index to be. So yeah, so you can pretty much just select like the date, and then we'd be dropping this column, and then date would be listed right here, and the location would be where date is now. And then when in place, obviously you're changing it in place, like on this line of code. Next, we also did reset index. So that was fun. I was struggling trying to figure out how to switch the date that was listed on the index position back to this date position. And all you do is use .reset index. Next, one of the things we went over was .apply lambda. So let's say, for example, you're working on a column and you want to be able to identify the different data types in a specific column. You can use this code, which in essence all it's doing is we're taking the data frame, we're going to take this column, which is a min temp, and then we're going to apply a lambda function. So each value in this specific column, which is considered x, we're going to go ahead and type it. So then we're able to see what the different data types are in this specific column, and we get the total count with .value counts. Now, with regards to identifying how many rows are in a column, you can use length .dataframe.column, and that'll give us the total rows of the column or data frame, whatever you're doing. And just for fun, something else you could do is you could do .unique, and then that would return the number of unique values from the min temperature column. So just kind of remember that. And then also likewise, something else to keep in mind, it would be df.mintemp .n unique, and then this one would also return the same. I guess not. Are we sure? Mintemp. I use mintemp .unique. Let's go ahead and see what this value is then. So the other one was 390, 389. So that means that there are null values in this. So let's go ahead and do drop .na equals true. I think. True, right? Does that work? Nope. What would it be? How do we drop the nan value? I don't want to spend too much time on this, but shift tab? Nope. Command shift tab? Nope. I'm forgetting. Okay, let's do it again. df.mintemp.unique. The struggle is real. Let's go ahead. Well, regardless, there's a nan value, and I think that n unique is the one that doesn't have it. Right? So drop na. Is that true? Default is true. So that we'll just use that as our like verification. So yeah, so that will just give us the unique values. This one does include nan or null values, and then this one does not. So let's go ahead and move on to the last couple right here. Now with regards to value counts for the wind direction column, what I wanted to do is I did the same thing of identifying the different data types by typing each value, which is x, aka the object, in the column. In the column. And then finally, perfect. One of the things that we went over also was the wind direction at 9 a.m. and we were going to locate any float value from wind direction by entering this .apply lambda of x is instance, and this is a built-in Python function. Yeah, and all we're doing is we're saying, okay, get the object and identify where it says float, because up here we were saying, or we were informed that it does have float and string values. And then finally, one of the things we went over was just, well, I didn't really do this on a flashcard, but if you wanted to locate something where there's a specific like value, you could do whatever the variable you saved your data frame and column as, and then go ahead and just do .locate.loc df wind, which is the variable where it's equal to true, and then identify the value counts. So yeah, that's just one example, and I won't go into too much detail. I know for those of you that are like able to read this, you'll realize that there's no actual true value populating here. Just know that before running this, I actually did not have this here. Yeah, so it used to read as false instead. So let's go ahead and move on to the flashcards for today. It's going to be spontaneous. We'll just see what kind of pops up. So I haven't actually selected yet. So fun fact, I do have a lot of these. And I will be going over React for myself later as I begin to talk about building startups or just trying to fix problems in society. That's kind of like a bigger goal of mine. Yeah, we'll kind of see what happens moving forward. But where is the Python Advanced Pandas? Okay, what's this? So for this question, let's go ahead and also bring up this, and let's make it a size 68 if I'm not mistaken. Yep, I hope. I can always adjust it. So the question is, how can you determine if your index is unique? So for those of you that remember or had like that were kind of paying attention a little earlier, what did I do to identify if all of the values in a column were unique? And I spoke about how they were, you might want to make them as a primary key, or that specific column would be the column that you would want to join on. So what it would be is data frame, I'm just going to let it capitalize, dataframe.columns is unique. Let's make this a little smaller. I think that should be good, like that viewing. But yeah, so should be dot is unique is what we're aiming for. But because we're speaking about the index, what we could also do is we would do, oh, that's dumb, index. So dataframe.index.isUnique, and then that should give us the unique values of the index. And in our case, the index is actually what used to be the athlete column, but we're saying that that's the index. And it does not have unique values. So just remember, if you want to identify unique values, dot is unique. Easy. And then this is just the answer to it. I'm going to go ahead and select this as easy again, so I don't have to see this again. Next question is, how do you update AOS? So in essence, this is giving us the answer already. But working backwards, how would you update AOS to AOS with a J? And then hopefully that's actually a Spanish name. I was just thinking Alfred might also be German, but I'm not sure AOS would be German. So it would be dataframe.rename, because we want to rename it. Rename. And from there, we'd go ahead and create the dictionary. And then, sorry, I didn't really give you guys a chance to think about it. I just kind of went. But always feel free to pause whenever you see one of these and try to answer the question yourself. So again, the point is, the more we practice it, the more repetition we'll have. And in due time, like with spaced repetition, you won't have to actually study it again later. But you will have to maybe once a quarter study it, which isn't too bad. So what we would do is, because we're now working backwards, let's update AOS back to AOS, and let's go ahead and keep it capitalized. So the old value, which is AOS, comma, Alfred, will then update to AOS, comma, Alfred. And then from there, we'll go ahead and do, I think it's axis equals index, or not, index. And we'll go ahead and do inplace equals true. Now, this is what I'm going to say the answer is, and let's go ahead and see if that's the case. So what does the following output? We have our summer data set. Summer, by the way, I'm just going to always use data frame df. But if we wanted to rename it, what we would do is we do dataframe.rename, and then I'm just going to call this a dictionary of string values. So it used to be AOS with a J, and we updated it to AOS with a Y. And then we did axis equals index and inplace equals true. So yeah, so that's really, really easy. I feel very confident in renaming a specific value that's an index. So I'm going to go ahead and click easy. And then here's another answer. So let's go ahead and see what it was and try to work backwards. So what does the following output if we use the summer data set? So maybe it's just a question. So we have our summer data set. To reset our index to a new value, how can we use the below? This is dumb. Let's take a second though. Let's look at it. So new index, which is the variable, and we've got a list. No. We have new metal, and then we're formatted for I in range. We've got 1 summer.index.size plus 1. What did I do? So I'm going to go ahead and click on show the answer. If you guys already know what the answer might be, I guess just have it already set up for you so you can recall. But let's go ahead and see what it was. So right here we have summer.index equals new index. So we're taking the index for summer, which is pretty much, I see what we're doing. Okay. And then we do summer.head. And then from there we use reset index. But in essence, what we did is we said that the index position for summer, our summer data set, is now going to equal the new index. And we assign this as a variable, meaning we created, why am I blanking? Oh, why am I blanking? List comprehension. But in essence, we took the string, which is metal underscore number, and then the format of I. And then from there, I is 1, and then it's just summer.index. But I don't know why we have .size right here. And I do understand where we get the +1. So we start at 0, or we start at 1, it looks like, and then we go 2, 3, 4, 5, and so on. But I'm just not sure where size would come in, .size. So let's go ahead and look that up. So pandas dot size. So we have our series, we have our data frame, and the array dot size, number of elements in the array. So it returns an integer representing the number of elements in the object itself. Well, why would we use dot size? That doesn't make sense to me. So let's go ahead and test it over here. Good old copy and paste. New index for I in range, and we'll change this to data frame because that's what we already have. And then the index is still 0 through 1, but I believe it should be updated. And then from there we use summer index equals new index, summer.index. So dataframe.index, right, index, equals new index. Now let's go ahead and do dataframe.head, if I'm not mistaken. Is that right? Yep. Let's go ahead and run it, and let's see what happens. But why do we have this size? So let's get rid of size. I want to test this again. And we get the error. So it can only concatenate a string, not an integer, to a string. So then does .size return the integer for us? Sorry, one more time. Can only concatenate a string, not int. What if we did this? Would that work? No. Index object cannot be interpreted as an integer. Perhaps because of this one then. So we would use .size. For those of you that are feeling ambitious, and for anyone else that might be a little confused that's watching this, please feel free to go ahead and drop the answer in the comments to why we use .size right here. Like always, that would also help me out. So thanks. So let's go ahead and delete this. And just know, in case you're curious, I actually did get this code from a GitHub repository. And all I pretty much did is, in order to create these flashcards, was just create little snapshots. And then I built out the flashcards myself. So that way I could at least remember them and keep studying these. What I did is I typed in advanced pandas for Python. So now that we know what we're doing with this, let's go ahead and move on to the next one. But let's go ahead and set this as good so it comes up again. So what does the following output if we use the Titanic dataset? So right here we're doing Titanic.age, or pretty much the age column of the Titanic dataset, and then .equals Titanic.age. So this will return true because all we're really doing is we're taking the age column and we're saying, does this column equal the same column in essence? It's just this is two different ways of writing Titanic, or writing the column value. So that'll return good, and I feel really confident with that. For those that don't know, feel free to take a screenshot or whatever and go ahead and practice this later. So I'm going to go ahead and click good, and I'll practice this in 10 days. Next, What's the following output? So if we have titanic.age.sortValues, and then we also have titanic.sortValues age. What's the output for both of these? I would say that both of these are actually, they will return the same thing. I know that titanic.age, we're pretty much selecting the age column, and then we're just going to sort by the values. And I believe it should be in descending order, so it would be the highest age at top going down to the lowest age. And we could also go ahead and add nan in last place. I don't remember what the other what the other position or the other metric would be. But my initial guess is that both of these will return the same thing. But let's go ahead and see. So both sort by age. We have babies on the Titanic, so that's why we have 42. Okay, that's just clarification. So titanic.sortValues will return the sort of this column. And then if we were to do age as well, that would return the same thing. Now, just to clarify, I should actually just get the Titanic dataset in here, and even the summer one. But for this video, I just kind of want to get it done, so that way my studies are done. So let's go ahead and do data frame, and then let's do the date. Let's go ahead and run this, and that will return the maximum date and then the minimum date. And let's go ahead and just identify. So sending is true. Okay. So it'll go from minimum value to maximum value. So in essence, both of these will return the same value. So let's go ahead and do one more thing. And then we'll do date. Let's go ahead and see. So again, we have the minimum value here. Metal number 58.8. Metal number 58.8. And I'm looking at the last three numbers. Okay. So they will return the same value then. Dot sort value, and likewise sort values and then with the column name as the value. Okay. So I feel pretty good with that, so I'll click easy. And then next is, how can you view the different data types in a single column? See if a column has both string and integers, or float and string, blank. The next flashcard will show you how to identify the string value. So if you remember earlier, one of the data frames that I came up with was, that I didn't come up with, that I learned from someone else. So what we would do is we take the column that we need to identify, so it'd be dataframe.column, and then we use .apply, and then we'd use lambda x, and then it would be the type, which would be also x. And then from there we do value counts. Now that would go ahead and return the count of all the different data types in a specific column. But I have a feeling that this is going to show something different. So let's go ahead and see what that is. I guess I was right. All right, perfect. The next flashcard will show us how to identify the str values. It should be both string and integer. So I'm going to go ahead and delete that. Perfect. So as I wrote up here, we have the data frame.column. This is the data frame. This is our column, meal price. .apply, lambda x, the type of x, which is our object, aka the value in each in the column itself, and then .value counts. So yeah, so that's pretty good. So I'm gonna go ahead and click as easy, or let's do good. Let's test it in a week. Next, we've got summer.index equals new index. So working backwards then, since this is our answer from last time, how could we create the list comprehension, if I'm not mistaken, and have these go in increasing value. So meaning we have metal number, and then we just go 1 through X. What I would do is I do data frame dot, no, we need to create a new index first. So new index equals, it'll be a string, model, metal number, metal, no, and then from there, squigglies, dot format, and we can also do an F string, I think. Anyways, format, and then that'll be I, for I in, stay, in, I think it's data frame dot index dot size +1, and then it'll also be 1 comma. So I get it now. Okay. So what this is doing then is we have the string value, and then we're going to say the dot format, which is I, and then this is pretty much just a one-line for loop, and all that's happening is for I. So this is every row in our data frame. We're going to go ahead and index the length of the data frame, meaning we're going to start at 1. So our data frame, even though it starts at 0, this value will start at 1, which is right here, aka 0 position, 0 index. And this will be 1. So this first I will be 1, and then we're going to go all the way to the end of our data frame. So we're going to go through each row will be 1, and that's why we use dot size. I almost feel though we could use the length of data frame instead. So with that knowledge, let's test it one more time up here. Oh no, did I delete it? I did. So let's go ahead and copy over this. And instead of using data frame index, the size, let's do, no, that wouldn't work either though. So what my thought process was is if we used length of data frame, then it would work, but the problem is that we would then miscount the rows because we're actually starting again at the 0 position. So we count 0, 0, the 0 position of the data frame twice. What did it though? I don't know. I guess let's just test it. Oh, the joys of learning. Backspace. Okay, what did I screw up? Right there. Perfect. And then from there we do data frame dot index equals new index, right? Is that what we did? And then data frame dot head. And let's go ahead and create a second one of these after I run this. Nope. Invalid character and format. So oh, thanks. What are we doing? Good. Nope. 2 elements. So how did I screw that up? Summer.index equals new index, summer.head. Dataframe.index equals new index to, let's go ahead and bring in our data frame. Let's go ahead and test it one more time. I could have done dot reset, but oh well. Yeah, so, okay. I guess I screwed up. I guess what I was thinking didn't work. But that's okay, because we learned something. It doesn't work. So index.size +1, boom. And it still doesn't work. Well, how did I screw up? What do we have? I didn't show the answer, so let's show it. So format I, for I in range. Good job. Now you work. Okay, good. But what I would like to do is let's import another data frame and let's compare the two. I just really want to see that because I want to see if my hypothesis is right. So we'll do df2 and df2. Good. And then it would be data frame 2 dot. So how did I create it? So we'll do new index 2 equals model number dot format I for I in range 1 comma len df2. From there it would be dataframe dot index df2 dot index equals what was it? No, let's see if it equals data frame dot index, right? Index. Is that right? So we got df.index equals new index. And then from here we have df2.index equals new index 2. And then from there I want to see if they're both equals to each other. I think I'm going to screw this up. Df, what was it called? df.index. Length mismatch. So that's why we have it then. So that's what my thought was too. And that's why I thought originally I was wrong. So what's happening here is we're in essence counting the 0 position twice, if that makes sense. But the reason we're getting the error is because of our length right here. And all the length really does is it's counting like the entire row count again. Whereas this one is just counting, it starts at 1, but we're counting at the index and then dot size. So I'm not entirely clear on size still, but the point is that we would count the index and then we'd count the size of it. And because it's an array, ND array somehow, it counts that size, the number of elements in the array. Okay, I guess the number of elements would be the number of rows. So I won't go into much more detail. I'll let that sink in. Hopefully tomorrow it'll be easier to remember. So let's actually leave this. I want to leave this up. Let's also go ahead and go back to this. I don't want to see this again for today's video. So I'm just going to click yes and then try to recall it a little bit later for my own benefit. So that was easy. So now we're working with sort by age. So again, if we wanted to sort by the age, we could do dataframe.age. Let's type these out so I can get some muscle memory. Dataframe.age.sortValues. And it is ascending equals true. So it's in ascending order. Right? Yep, so data frame age, sort values, is the same as data frame sort values by age. So I feel pretty confident with that. And then this looks like an answer. So what sums all values that are not nan, null, or missing? It sums all values that are not nan, null, or missing. This sounds like a riddle. What would sum all the values that are not nan, null, or missing? Is not null an option? Let's see. Age.sum skip NA. Okay. Age.sum skip NA equals true. And then for those of you that are curious about like where age comes from, think of it as being saved as a variable. So age equals titanic.age, and then from there we do age, but it'd be capital, but we'll make it lowercase. So if we want to sum everything up that is not nan, we'd use skip na equals true. Age.sum skip na equals true. Okay, and I'm assuming that we'd be able to use skip na for also .mean, .std, if that was one, .mode, and all of the other like .div, and the rest. Yeah. So I'll set that to hard, and then I'll come back to that later. So what does the following output? So what we're going to do is we're going to say titanic.sort values. So we're going to sort by the p class, by sex, and by age. And ascending true, false, true, and place equals true. So if we're doing it by ascending, then I know that the values in p class are 1 through 3. So that means we're going to start at 1 and we're going to go down to 3. But we're also going to start with, I think, female first. So it would be everyone in P class that is class 1, everyone that is female for sex through class 1. So we're just focusing on class 1 for now. And then it's going to be the youngest person because of age. So it's going to be the lowest number. And then we're going to go up to the highest number. So everyone in class 1 for P class is going to start with P class of 1, female, the youngest member, until we're pretty much reached the oldest member, and then there's no one else to count. And then it will switch to still P class of 1, but then it'll switch to male. And then it'll start at the youngest male and then go to the oldest male. And then it'll go up to the second P class, female, youngest to oldest, and so on. So hopefully that made sense. If it didn't, try to visualize it. I'm sorry. But if we were to go ahead and run this, so it starts with male first. Okay, well, regardless, the thought process is still the same. So it sorts by P class, sex, and age, but it goes in ascending order by P class. Oh, because this is false. Okay. So we have the sex in the not ascending order. If it was female, it would show. If it was female, it would show. Yeah, okay. So like I thought originally, I was thinking that this was true for whatever reason. I feel really confident in it. If I was you and you're not too confident, go ahead and take this code and run it for yourself. I think in the next video I'll bring in the data sets so that way we could just go back and forth. So let's go ahead and do easy. And then for this one, what's happening here again, all we're doing is we're going to go ahead and take that meal price column and identify the different data types in the column. And we're going to go ahead and count how many occurrences there are of that specific data type. And I think I'm going to finish shortly here. How can you view the different data types in a single column? See if a column has both string, integer. Yeah, it's in essence one of the ones we did over here. This is very useful and will probably be useful for just for basic data analysis. So let's do good. I feel really confident in that for me. And this will be the last one, and then we'll switch over to Google Colab. So what does the following output if we use Titanic dataset? So if we have Titanic dataset and we have Titanic.n smallest, n equals 2, columns equals age. So I know we're going to go ahead and be selecting the column age, which is right here, and then n equals 2, as well as n smallest. So I'm blanking on this right now, but if I had to guess, we would start at the smallest and we'd go up by an index of 2, maybe, meaning we'd start at 0 and then we'd skip 1 and go to 2, skip 3, go to 2, and we'd skip every odd number, and we'd start at the smallest value and go to the highest value of the age column. That's what I'm guessing. So sorts by the smallest value, n equals the number of rows, so we're only selecting 2. Okay. I don't want to get confused with this just yet. I want to let this sink in. So all that's happening again is we're selecting 2 rows, and then we're going by the age column, and we're just selecting the smallest individual. And they both survived. Yay. What else? So we could also do Titanic.n largest, and that'll give us the largest value. Or as other ways of sorting by the data. Or as other ways. That sounds weird. So Titanic.locate, Titanic.age.index, min. Okay, so we could either use n smallest or locate the smallest IDX min, which I'm assuming IDX stands for index. It would make sense at least. Okay, hopefully I remember that. I'm going to click good, and we're going to go ahead and stop right here. Yeah, we'll go ahead and stop right here. So now working with the data frame again, let's go ahead and check that out. And let's see if I remember anything from what we just went over. So we still have metal as number 1, so let's go ahead and reset that. If you had to reset your index, how would you do it? We would do data frame dot reset index, and we would do is inplace equal to true. Do we need to do that? So inplace does need to equal true because it's set to false. Oh, thanks. df.head. Come on. I suck. So I was expecting to get rid of it, but I mean, all we could do now then is, if you had to, how would you drop a column from a data frame? Well, we would do data frame.drop, and from there it would be called index, and from there it would be axis equals 1. And let's go ahead and see. And now we've dropped our index column. But I mean, at least we were able to reset it, right? So we've done this in place, we've reset the index, and we also have drop. And then what else do we go over? So we went over the smallest value. So n smallest, right? So data frame dot, let's go ahead and check out what the smallest value would be for, how about rainfall? Data frame dot n smallest, and let's go ahead and choose 5 rows. N equals 5. Yeah, let's go ahead and do n equals 5, and then we're going to go ahead and do what's it called? Rainfall. So rainfall, and let's go ahead and run it. Follows keyword argument. What was this keyword again though? Was it column? Is it column? Rainfalls? It is, perfect. So we're able to see the smallest value, which is 0. I was expecting like a 0.001 or something for whatever reason. And we still have the index, so we didn't save it. Let's go ahead and do inplace equals true. Run it again, and now we have our values. Perfect. And it starts at index 1, 2, and so on. Okay. Let's go ahead and view, what else did we go over? So we went over the smallest, we went over resetting our index. Trying to think of what else we went over. We had the sort. Skipping, that's right. So how would you sum the total values without summing any NaN values in a specific column? Or better yet, how would you, instead of sum, how would you gather the average of the column without adding NaN or null values? So kind of easy since we already kind of looked at the answer, but it would be our data frame and then our selected column, so we'll just stick with rainfall, and then it would be dot mean, and we would use skip NA, which is equal to true. And then from there, we go ahead and run it. And this would give us our total average for rainfall for Australia. So yeah. So I feel a little confident, and I think for the next video that I make, it's going to be a little different. Instead of going over a completely random data set, I'm just going to bring in both the Titanic and the summer data set, and then we're just going to work from it in Google Colab. But I'm going to go ahead and end this one here. I'm going to create more flashcards for scikit-learn, and then hopefully React. I really need to get to that as fast as possible, mostly because of what I want to create. So yeah, so I'll end this video here. If you guys are interested, please feel free to link a or book a Snugg session with me. And all Snugg really is pretty much one-on-one conversation, and then I can help you out with anything related to SQL, and likewise even Pandas, and a little bit of scikit-learn and TensorFlow and PyTorch. But I feel really confident in my SQL and Pandas, and I just need to refresh on my scikit-learn before moving on to TensorFlow and PyTorch. And all I'm really doing is pretty much just creating flashcards for those as well. But yeah, I'll go ahead and end this video here. So yeah, feel free to book a session if you feel like booking, but otherwise I'll go ahead and see you in the next video. So thanks for watching this. Five, four, three, two. So yeah, so I think we've kind of gone over quite a bit today. I know I'm not going to be able to recall all of the other flashcards that we went over since they were quite brief, but I'll go ahead and bring in the other data sets, like such as Titanic or Summer, so that way it's easier to see on Google Colab. But I'll go ahead and end this video here. In my next video, done. Don't be naive. Don't be naive. Don't be naive. 5, 4, 3. So I think I'm going to go ahead and end this video here. Fuck. 5, 4, 3. So I'm going to go ahead and end this video here since I'm kind of running short on time today. But ultimately what I'm going to do next time is I'm going to bring in the other data sets, the Titanic and Summer data set, so that way we can run both data sets and see what the output would be in case we ever need to see whatever the code might be for our flashcards. So that way we can compare them. If you guys like, please feel free to book a Snugg session in the link below. All that really is it's one-on-one conversation. I could help you guys out with Pandas or SQL, or even possibly some scikit-learn, as well as some deep learning for PyTorch. My skill set's more advanced with Pandas and scikit-learn and SQL, but yeah, just if you feel like you need some help with tutoring or something, just let me know. But otherwise, I'll go ahead and end this video here, and I'll go ahead and see you guys in the next video. Thanks. How long are we? 48 minutes.